everything changes.
Life. Life.
Good evening, everyone. Hope you're having a more than pleasant week. We went through some PGP stuff on Sunday night, and I think I almost put myself to sleep with it. I mean, it's important stuff, but it is a bit dry at times. It is good once you've got a handle on the whole system, though. You can make it do some cool things for you. But we were gonna. My microphone is already drooped. This always happens. Solid start to the night. So, we were going to do some intermediate PGP stuff tonight with regards to basically having your own key policy and keeping your master key offline, and how and when to use your offline key. But this afternoon, the thought of doing that almost made me actually cancel the stream. Yeah, cute Peleus. Good to have you around, Peleus. So, we're going to do that another night. I thought, well, the reason I didn't take tonight off, I would have loved to have taken tonight off. I'm feeling a little bit worn out. But I won't be streaming on Sunday night. I've got prior arrangements then. So I didn't want to skip 2 in 1 week. And we're going to do something that'll keep me at least vaguely awake tonight. I threw it out to OJ and said, OJ, what should I stream? Because I don't want to do PGP again. Which I promise we will do sometime shortly. And then following on from intermediate PGP, we will all crack open our YubiKeys and learn to put PGP subkeys, including SSH keys, on YubiKeys, which I think is really, really cool. And we'll do that after we've done the intermediate stuff. So OJ thought the title of this binary, shitsco, was funny enough that we should try it tonight. So I haven't done this one yet. I think OJ said he may have done it back when the CTF was out. This is from the DEFCON 22 Quals, so a couple of years old now. OJ said he may have done it. I'm not sure if he's sure that he finished it or not. I said, alright, can you go read a write-up to make sure I'm not getting myself in too much trouble? And he's read a write-up and he said it's reasonable enough that we should be able to tackle it tonight. So the usual thing, if the audio is funky, if you can't hear me, if the music's too loud, if the music's too quiet, give me a yell, we can tweak it together. Yes, Pelias, that is PGP doing its job, making people not want to use it. Cool, Mongo's done it. That's Mongo can make sure that when I'm wandering off into the weeds, we get steered back on course. Now, I probably should have got OJ to look up the briefing, because normally on things like the CTF write-ups repo, you can look at the briefing, but sometimes the links to the write-ups can spoil the challenge a bit. So I didn't want to do that. If someone else has a minute and can find the write-up, not the write-up, the briefing for shitsco, please do so. Please drop it in the channel so we can all have a squiz and see what the challenge briefing was at the time of the CTF. But otherwise, let's kind of get into it, I guess. We get given a binary. From Shellstorm, we only get the binary, not the briefing. So what is it? It is it's an ELF 32-bit binary. It's dynamically linked against libc. I'm guessing we've got a build ID, and it's stripped. So we don't get debug symbols to make our lives easier. That's alright, we can make do. Let's go and chuck it here. And open it up in IDA and see what we get. Should probably also run it, see what the interface to it looks like. Shitsco, there we go. I freaked out about 5 minutes before the stream started because I actually didn't have a VM. I'm re-rolling my VMs because Windows 10 is really annoying me. Didn't have IDA installed in a VM, just like last week with Firefox. We didn't have any debug tools installed anywhere, so got that done just before had to start streaming. So that that would have been fun otherwise, not having IDA. Let's see what it looks like when we run it. Same thing as usual, by the way. If you need my attention in chat, please use my name so I get a little alert. Otherwise, I'm going to keep on trucking, and there we go. Someone's done the right thing. No briefing, just given the binary and a service path. Awesome. Okay, cool. Thanks, Mongo. Thanks, Pelias. How's it going, the Wizzy? Good to have you around. Null system, I'm not using DWM. I'm using i3 and Tmux and Zshell and URSI and Windows 7 and IDA. DWM, I'm guessing that's a window manager, but I'm using i3. So why in the actual fuck am I using DWM? Because I'm not using DWM. What do we go? Okay, failed to open password file, no such file or directory. We should probably find out where it's expecting a password file to be so we can go and put one there. Because for the challenge, in the case that it's running on the server, the challenge server, it would have been fully set up and populated with a password file somewhere. Maybe the password file is the flag. I'm not sure. I'm not sure if we have to shell it or just leak the flag. But it sounds like on the day of the challenge when this binary was handed out, you only got the binary and this really short briefing saying service is running at some IP, capture the flag. So people on the day would have gotten the binary yelling at them that there's no such file or directory, and it would have been on them to either put something there or patch that check out. So that's now our job. Let's go look at the main function and see what's going on. Doesn't look too bad. What have we got? We got call to puts. We're putting some nasty string. Before we do that, we've got a call to this function here. Here we go. We've got the error. Failed to open password file. So this is as far as we're getting when we run the binary, and then a call to exit occurs. So if you fail to open the password file, the whole process will just tear itself down. You're not going to get anywhere too quickly with it at all. So we've got some options. We could patch this check out. We could patch out the fact that it's opening anything. We could patch out the call to this function, but it could be important. We should probably go put a file at home shitsco password that the user who runs this binary can read. Let's just go and hack that in now. This is a Docker container. I run all my challenges in Docker containers so I can go and do stuff and not really care. Sudo chown Justin. So we've got the home directory for shitsco, which is now just owned by me. Oh well. Is it password? Home shitsco password, yep. This is the this is the password file contents. I don't know if that's supposed to be the flag or what. I guess we'll find out. Now if we run the binary, then we get a banner. Shitsco. Welcome to Shitsco Internet Operating System, iOS. If you haven't figured it out, this is a play on the word Cisco, and Cisco's platform operating system is called iOS. For a command list, enter question mark. Okay, so we can enable, we can ping, we can trace route, shell, set, show, credits, quit. If we do enable, is that asking us for the password that is in that file? Whether it's the flag or not, that's probably the password that in this case it's asking for. What was the... You know what, let's just go and edit that file to be something simpler. Password 1. Of course... What? Do you have to like bring your own null terminator? Maybe? Let's kick off a pwnable script so we can interact with it with style. And because I'm ambitious, I'm going to call it exploit.py. This is just the usual song and dance, setting up context, setting up pwnable to make sense, so we can pop GDB in a tmux split. Can't type on stream or off stream. Let's just go T interactive for now. Oops, no, that's not at all what I wanted. That's not what I wanted. That's what I wanted. Twitch, let's go. Alright, cool. So now we've got a little simple script that basically starts the shitsco process and then drops us to a shell. So now I'm curious, because we were doing before enable, enter, password 1, enter. I mean, this could maybe be useful as an info leak. Like we can probably leak, I'm guessing, stack contents up until a null terminator. I'm guessing though that the shitsco iOS maybe wants you to bring your own null terminator. I mean, we can dive into the disassembly in a second. I just wanted to get a feel for the interface to this thing. Let's go t.sendLine and actually using Python go and shove the string enable down the throat of this thing, and then let's t.sendLine password 1 null byte and see if when we send our own null byte it'll actually, I'm guessing, because with, I don't know if people have used Cisco routers before, but when you do enable you get challenged for a password. Once you put the password in, you then get, you know, super user functionality. Now if we run that exploit, nope, the password isn't password 1. Okay. Is there a new line at the end of this file? Yup. What if we just do this? Will it work? Huh. Right, because it's probably doing like a read up until new line, and so we're not actually bringing this to the party. Vim home. How do you get rid of the end of like the implicit new line in a text file? Does anyone know? You only make that mistake like 14 times, hey Pelly? It's like by the 15th one you've learned, yeah. Yeah, I did Peleus. That was cool. And yeah, you're right. The because I think you need cap net raw capability. which Docker gives you by default. So yeah, you can totally, I mean, any kernel bug that a Docker container can tickle will be a like a breakout. But yeah, that was interesting. Have you given it a go, Pellies? Have you tried running it? Yeah, quite. Good call, Mongo. Yeah, that's good idea. Let's go and let's do that, hey. Alright, so echo-n should mean we don't get a trailing new line. Who needs a text editor? Just go and like echo all your stuff to your text files. Alright, let's try this password one bizzo. See if we can at least tickle this enable functionality. Even though against the challenge server we're not going to know the password. Okay, so we get authentication successful, and now we get a pound prompt, which means we're elevated. So I'm guessing now we can do something like shell. Yeah, there we go. No. Nah. Oh, that's awesome. Cheeky. Very cheeky. I'm guessing now that we're elevated, we can do special stuff. Let's just run shitsco and see if we could have done that flag command without being elevated. Ah, yep, so you don't get the flag command unless you are elevated in privilege. Okay, so that might be one way to get the flag. Either discover the password and log in, or exploit the system so that we become elevated, and then use that flag command to go and get the flag. Let's make sure that flag function actually does something useful. Okay, so this function here looks like it's basically just reading the enable password into somewhere. Doing an fread to a local variable. Hang on. Doing an fread. So we're opening home shitsco password. Oh, this is a move. Okay, so we're putting a absolute address into that local variable. Is there some sort of optimized call shenanigans going on where these aren't actually... Yeah, okay, we don't have an EBP. Yeah, we've got like stack optimization going, just to make things difficult. So, okay, this looks like it's the pointer to the location at which it's written, which is in BSS. Okay, so it looks like this this function is opening the password file, reading from it to the .bss segment, so we can rename this here to ENA password. So it's reading it into what we're going to call the ENA password offset. Up to OX20 bytes of it. It's the size parameter to fread. Whatever it is, we're putting a 1 there. Oh yeah, and then fopen returned a file handle into EAX, which was then the string we're reading from. Okay, cool. That makes sense there. We do the fread, we then test the exit code of fread. Then we close the file, and then we're done. Do we always close? Why do we only sometimes close that file? I mean, we don't really have much ability as remote attackers to influence anything at this stage anyway. I'm just curious. So this function here is read password file. And it's just going to read it into ENA password. Cool. So we've figured that out. We're on our way. Parks, good to have you around, dude. Welcome. Yeah, there were some cool challenges at KiwiCon. Should do the PHP one, the auth token stuff. I really like that one. One of the last challenges, actually, I think the last challenge they opened was quite cute. Okay, so we're reading the password file, we're printing a stupid banner. Welcome to shits. Welcome to shitsco iOS, blah blah blah. We're printfing, blah blah blah. We're flushing stood out, blah blah blah. And then we do some stuff. Alright. I'm going to ignore this for now and just see where we're ending up. Okay, so at the end of the function, there is a way to make it return by the looks of it. Yeah, there's a way to make it return, but there is a stack canary check going on. So ESP plus 6CH. Yeah, so we don't have an EBP. We've got like optimized stack operations. Hey Mongo, any tips for working with optimized stack operations? Like, am I cool to just go and rename this 6C to be stack canary? Or is there a way to get either to basically fake EBP and actually create the local variable shenanigans that we're used to? If you haven't met Mongo yet, everyone, he is our resident IDA expert who schools me on all the ways I should be using my tools. So we know that 6CH is, yeah, that's the stack canary. So we can cause the thing to return somehow, but there is a stack canary check. Actually, we should have done a check sec on this. See what we're up against. It's GDB. What do we got? ASLR off. Everything else is on. Partial railroad. Okay, cool. Cool, we can work with that. ASLR is off. So we've got a couple of functions being called here. What are these doing? Okay, so we can rename the 6C, but is that a good idea to actually rename 6C? Because it's not exactly a local variable at this stage. Or I can edit the function settings and remove the BP based frame. Okay, yeah, that sounds a bit iffy to me, because won't that then rename 6C anywhere else it's being used? I'm going to play with this. Edit the function settings. Okay, so turn off the base pointer based frame option. And we get some local variables back. Yay! That's cool. That makes life easy. So we can see here that we're loading the stack canary and then dropping it into var 10. So we can rename that to be canary. So we figured something out. We've only got a couple more to go. Okay, so it looks like if we can get this function to return -1, then we go down to the whole return thing. Cool. I mean, is it going to return if we just give like a garbage thing to do? Like if we tell it to do that? Oh no, we get invalid command. Oh, it's probably quit. So quit will print thanks. And then probably return -1 from here. Or not. Got a call to read. Not a lot else. Where was that thanks message? We've got like a bunch of code that IDA hasn't recognized as actually being a function. We've probably got like a crazy case statement jumpy thing going on somewhere. Righto. What's this special thanks? We haven't seen that yet. Cute. We've got like the fake shell stuff. Sleep for 5 and then puts, yeah, right. That's awesome. Okay, here we got the opening of flag. So this must be like the flag read function. Yeah, so here another function kicks off, but all this stuff here IDA hasn't actually recognized as being part of any function. So we'll probably see some weird, crazy call jump thing somewhere into this area of code if we keep on digging. But I'm guessing this might be when you exit, maybe. We could check with the breakpoint, but I'm not too interested in actually making it return just yet. So I've got a call here. Let's pick this one apart. What's it doing? It's doing a read from arg0 as a file descriptor. Yeah, so if we trace this back, so here we've got a call to read. If we look at the file descriptor it's reading from, which is probably going to be stood in, we trace ESI back, then ESI came from arg0. So what's the 0th argument, or the first argument to this function? Yeah, 0, file descriptor. There's got to be a better way of documenting this. I'm sure Mongo's gonna yell at me in a second. Oh, that totally just renamed stuff for me. Did it? Yeah. No. No, didn't. So arg0, we know is the argument for the file descriptor. Mongo, I'm sorry for abusing you as my doco for IDA. Is there a way if we go and actually tell IDA that this function here, that this argument is the file descriptor? Is there a way that it can like pretty print that fact over here somewhere automatically? Because that'd be totally wicked. Is there like a view options that I need to turn on? We should turn that on because that's totally cool. Yeah, I'd be curious if there's a way. I'll just go and put it in for now. So that's the file descriptor, which you can see is being set to 0, so we know it's going to be reading from stood in. Go back to this read, then it's reading into the buffer pointed to by EDI, which is the address of variable 1D, which is being where it's read to, so we'll just name that the read dest for now. And it's reading 1 byte. We can see we've got like a loop going on here, so it's probably just reading until it gets a new line. Guessing EBP, which we can see comes from an argument. It's probably the command delimiter, like a new line, because we can see we've got a loop here, like a read loop, which is probably reading up until it gets a new line. Highlight the function being called and press Y. You can set a declaration for it, which includes argument names. Should get propagated to the call site. Okay, cool. So I'm guessing this here, press Y. So we've got an integer file descriptor. I put that there before. I just realised my fan's like blowing a gale into this microphone. I'm just going to turn one of them off just 1 sec. Nope, it's not my fan, it's just raining outside. I can't help that. Okay, cool. I might play with that another time. This here we know it's the file descriptor. And then so what was that next up? What was going in? Where did EBP come from? EBP came from argc, so the third argument. Apologies for the rain noise, by the way, but that can't be helped. Maybe I'm off by one somewhere, but we can see here that, yeah, this argument here, it's moving the character new line. What was the totally sweet trick to make that actually be a character? It's probably not actually wanting to do that. But we can see, yeah, new line's being passed in. So that's like the command delimiter. So that's cool. So that's where we get the new line that delimits commands that will kind of cause this loop to break. So that's this one here. Yep, cool. Oh yeah, it's the fourth argument, not the third. My bad. Zero indexing. So that's arg command delimiter. So we've got the compare between the character that just got read against the delimiter. We've got a compare of the low bytes. And it could fall through to here, then go up to here. So what's this comparing? Moving arg4 to edx, which was the new line. Then it moves AL to EDX plus EBX. Okay. Oh, down here we've got a -1 being set. So if the read fails... Yeah, because we've got a read of one character, and then we test EAX, EAX, and then go this way if EAX was 0? No, not 0? Yeah, not. Test, 0 flags, not set, because if they're equal, the 0 flag will be set. Sorry, if it is 0, the 0 flag will be set. I'm like way in the weeds of... I should learn assembly, but I'm guessing this is probably if the read fails, if the user's disconnected, then we kind of bubble -1 back up to cause the return to occur. That makes sense. Cool. Otherwise, we check to see if it was a new line, because EBP came from the command delimiter, which we've seen to be the fourth argument, which back here we saw to be 1, 2, 3, 4. Yep, new line. So I'm guessing that means the delimiter between commands. Please fix the weather. Not as well as I should. I kind of sit there and go, hang on, test EAX, EAX, JG something. No, I'm just going to kind of hope that it is what I think it is and move on with life. Kane, good to have you around, dude. Welcome. Welcome to watching me fail to use IDA and fail to pwn stuff. But apparently people enjoy it, so hope you enjoy your stay. We should catch up for a beer sometime, dude. It's been a while. Alright, so we're reading in a string in a loop. And then in certain circumstances where okay, so we've got a compare of the new line to it. then a JZ, which I think is going to go down the green path if the compare was successful and matched, which is going to add to ESP, rewinding the stack, and then restoring some variables and returning. Okay, so as soon as it reads a new line, it buggers off. If it wasn't a new line, it's probably okay, it's storing it. Yeah, it's taking the character we read and actually storing it in, I'm guessing, a local variable. EBX, one of these is going to be a counter. Yep. So EBX is a counter, which counts how far into the string we're reading. Probably starts off as 0. Yep, X or EBX. EBX starts off as 0 because we're writing from at the beginning of the string that we're storing it into. And EDX is probably the base address of a local variable. Oh, hang on, no. EDX was passed in by the caller, so the caller gets to tell this function where to read the command to. So this is the argument for the input dest. Yeah, which is kind of what-ish. It's the second argument, which is EBX, which tends to be a local variable of main of size OX50. Yep. And I did see OX50 getting passed in here. That's probably the maximum amount of characters to prevent a stack buffer overflow. So we could dig into the mechanics further, but I think I've got a good handle on this. This function here is going to read a command. Up until a new line gets read in as a character, it's going to read, I'm guessing, up to OX50 characters. EBX, I don't know really what... Yeah, EBX was the destination. Gee, that's some decent rain. We're reading from stood in. Okay, cool, so we read a command. I think we've got that one pretty well understood. We can always come back to it, look for bugs later on, but now we know at least what it does. And then we check to see if read command return -1 for a failure. And we go down this direction if we do, where we return after checking the canary. Does read command really return anything interesting otherwise? Yeah, it returns the counter. So this is going to return the number of bytes read, which is cool. Understood. And then based on EBX, which we know to have been should rename this to the user command. EBX, which we know contains the pointer to the user command buffer, gets made to be the first and only argument to this function here, which probably dispatches to the correct function handler. Yep, only one argument, which was the command. And then it's probably going to, dispatch to all that code we saw hanging out. Oh, this looks horrible. Oh no. Maybe we're not going to get this one done statically. Maybe we're just going to have to chuck stuff at it as human fuzzers until we figure it out. Yeah, because what else did I want to do with my life on a Wednesday night? Alright, I'm just going to have a quick flick through this to see if I can make any sense of bits of it. If so, we might pull apart bits. Otherwise, we'll just go straight back to Pwn Tools and just chuck shit at it till it breaks. Yeah, now you can hear the rain. It's picking up. Oh. Am I imagining it, or do we have an uninitialized I don't think it's going to give us anything, but looks like there's a massive loop here. Like we start up here, I'm guessing we kind of fall down through these blocks, but then we have the ability to loop back up to one of these two. Which one was it? This one here. So what we're doing is we're doing a stern comp. Stern comp, does that give you the ability to actually specify how many characters to compare? Yeah, it does. Third argument is the size. So first of all, like the first time through here, EAX is, I don't know, whatever the parent left it as. So we're comparing the parent's number. This can't be right, because that could crash if EAX started off big. But maybe it always is pretty trivially sized. Nope. Weird. Hang on. No, I'm somewhat stupid. What does EAX generally start as? Aha! EAX will start off as the number of bytes that were read by read command. Okay, so that makes that's I'm cool with that. I'm down with that. But like the first time through this massive loop, we've got a stern comp of EAX, where EAX is the number of bytes read by. Oh no, Sterlin's going to populate EAX. Yeah, never mind. We're good. EAX will be set by Sterling. We're doing a Sterling of S, and S I'm guessing is the one and only argument. Nope, it's not. What's in S? Move the pointer in EBX to S. Which is the pointer S2, which is local variable, but we're populating it with hang on, that's not a local variable, that's an argument. Never mind. with EBX. EBX is... oh yeah, it is S2. Yeah, we're like stuck up the top here. We're not gonna get through this. Let's go play in the debugger for a bit, then come back and see if we feel like reading more assembly. Let's go and just get rid of these two, and let's go and run it. Let's go and attach GDB. So I'm going to kick off a empty list for GDB command. GDB command dot append C for continue. GDB command equals new line dot join. GDB command. So what this will end up doing is creating a string with C, but the cool thing is we can set breakpoints later on, things like break main, and it'll just stitch them together with new lines. And then when we do pwn.gdb.attach, it will execute the contents of that string straight up as a GDB script to save us the hassle of doing breakpoints manually. We can just put them in through Pwn Tools. So I'm going to attach GDB and then just go to a shell. Did I not save that? Where is my GDB? There's my GDB. That. Oh, was I just running shitsco? Not the. Yeah, I wasn't actually running the exploit. Okay. Yep. Cool. All right. Now we got GDB. Command list. So we can do enable, which we know that we're going to need the password for. We can do ping. Docker's probably being a jerk. Maybe. Or maybe, yeah, because ping's normally set UID, isn't it? So we need to run this as root if we actually want to ping. Same thing for traceroute, maybe? Okay. We can do shell, which we know is a total troll. We can do set foo bar. We do show. Okay. That looks like it could be interesting. Credits. Oh, that's that Easter egg there. And quit. Set foo to bar 1. Show. Set foo to bar. Show. Yeah, this set show bizzo looks interesting. We should probably just jump straight to the code that does the set and the show. The other thing that was cool was we could do enable, enter a password, new line, and we get a leak of some stuff on the stack, I'm guessing. And we can kind of control... Yeah, like if we hit a null byte in that leak, we can probably then hop over it by sending more data. We could probably... Yeah, we could leak... How much stuff? Let's go look at that password stuff. So we want to look at the password stuff, the set stuff, and the show stuff. So I reckon that password one is an info leak. And then the set and the show, I reckon, just feel interesting to me. Where was all that? Where was all that code? I reckon these here are the actual function handlers that handle each of those operations you can do through the menu. Like, yeah, you can see here's the credits code. We can see here is the drop privileges code. This looks like it's, yeah, that's the exit code. Cool. So these are actually all the function handlers. Here's the troll shell code. Here is the flag, which is only doable once you're escalated. What's this one here? Or is that just a spurious location? Oh, there's... Oh, yeah, okay, so we've got code cross-references listed here. Oh, it was just referenced by itself. Okay, so we've got like a loop. I reckon this here is a function, but there's a loop inside it, so we get this marker here. That's cool. I'm okay with that. That was a good one. Yeah, cheers, Volko. I'm just digging through them at the moment to see what jumps out. Have I tried X-rays? No, I haven't. I don't have the no. Sadly, I wish I did. Maybe for Christmas. Maybe Santa will give me X-rays for Christmas. Kane, have you used Binger? I haven't jumped on board yet. I haven't given it. Would you how would you rate Binary Ninja, Kane? Yeah. No, I don't. I mean, my laptop's got its own battery, but the cable modem doesn't. So if I disappear, we know why. It's because my room's gone dark, the laptop stayed on, and the cable modem has disappeared. Are you an IDA user, Kane? And how have you found Binary Ninja to compare to IDA, if you've got IDA? Is this the show stuff? Hold up, so you can do show. Can you do show foo? Yeah, show foo 1. That's that wasn't really kind of obvious through the menu. Just by seeing this here, I thought, oh, is there a way to actually show particular things? Nowhere near as busy. The Python, okay, so the Python API is good. Yeah, cool. I did read the 100 cuts and the 1,000 cuts by the... Who did those? Nope, not cut. Cute cuts. Trailer Bits. This was if people haven't read this, you should totally read this. This was what actually was the first. This is what told me Binary Ninja existed back when it was in beta, and this article made me go, ooh, it's one to keep an eye on. So I'll drop that in chat. If people haven't read it yet, go read that. It's really eye-opening as to the kind of things you can do when you learn to script stuff and you learn how to use your tools. So very much recommended. Okay, so we can show specific. Show %x. Not gonna happen. Yeah, cool. Yeah, so here it is showing the value of things that have been set. So here's the ping code. Can you just not ping from Docker? I can. It's probably because I've got a debugger attached that ping's actually not getting setuid magic privileges. Yeah, that'll be what it is. Okay, so we do have ping. It's an execl. That doesn't look injectable to me. This doesn't smell like a command injection challenge. So there's all the ping stuff. And all these codes are broken up in weird ass places. Like here it is for, I'm guessing, the when you try to set stuff but haven't named it. Yeah, like all the functionality is actually broken into tiny chunks everywhere. Oh no, I'm just an idiot. Here it all is. So there's a return. Okay, so I'm guessing this here is the set code. Which actually calls another function. Okay, I reckon there's something in here. So we've already set food bar. Okay, so if something's already set and you do a set foo, it unsets it. Right. Let's just go and chuck a bunch of characters at it. Oh, wasn't happy about that. Oh, that's right, it only wants to read in up to OX50 characters. Cool. Let's do A times len of set space plus 1 for the B plus 1 for the... Let's do 1 for the new line, let's go. And then B times 1. See if we can set a really long variable. Misplaced my brackets. Hang on. A times OX50, I think it was, minus all that garbage. Alright. Off by 1. Well, that looks boring. Boring. Let's see if we set a really long value. Let's swap these around. Boring. Alright, so that's not the trick. It's not an overflow when you're setting or getting these parameters, these variables. Quit. What else could it be? Enable gives us the leak. Like, we're not going to guess that password in the challenge scenario, so that's not going to be it. I'm guessing ping and traceroute are both boring. We should look into them, but we should probably look into them. Let's go and have a look at ping. 2 references. Guessing it was there and there. 1E, 2A, yep. Alright, so what's happening with ping? Ping and traceroute kind of handled within the same function, maybe? There's like a fork and some traceroute stuff. Maybe not. This is probably the beginning of ping here. Why is it forking? Oh, it's forking and then it's going to do execl on the child. Okay, yep, gotcha. So the fork's going to be pretty boring, I reckon. This stuff here that could be interesting. Yeah, good idea, Kane, because you're right, yeah. The password is on the heap. Good point. Good point. Let's go back to the read password file, find the crossrefs. Oh, it's actually hard-coded. Where was it? Here. Alright, so after the password, we could possibly leak this here. What is it? It's referenced in a bunch of locations. It's set to 0, and then it's compared against 1. It's loaded into EAX, it's set to 0, it's set to 1. Looks like we can leak a 0 or a 1. Which might be whether you're escalated or not. Mind you, we can only leak it because we can't control what's getting read into that ENA password buffer on the heap. Not the heap, it's in BSS. So we could read, I'm guessing this is whether we're escalated. So we move 0 into it, like right at the top of the program. I'm guessing the place where we move 1 into it is going to be during logon. Yeah, authentication successful. So this is called, we're going to call it is elevated, because it stores whether you're elevated or not. And then where it's being set to 0, that's where you do your privilege plummet. Okay, so that stores, so we can leak whether you're elevated or not, but we can't write to it. Like, we may be able to spike it later on, because if we can spike that, then we can access the get flag function, and that should give us the challenge solution. But we would need to be able to write to it. So leaking it's no good, and it did butt right up against the end of BSS. Like we could, does this follow straight on? Like, can we leak the GOT? Is extern the actual GOT? Or is it the PLT? I think it's the PLT. So we can link to PLT, which sounds totally boring. And we've really only got the ability to read OX50 plus a bit bytes away from this. So we could leak this, but I don't think it's going to be useful. 50 is going to be A, B, C, D, E, F. So we can leak up to and a bit past F0. Which is just, yeah, more PLT. There's nothing valuable in the PLT, is there? Just pointers into the GOT, really. Or is it the GOT? It is the GOT. Okay, so we can leak pointers into libc, which could be handy. What is extern? Is extern the GOT, or is the GOT somewhere else? Where's the segments? Alright, so what is in extern? Whole bunch of null bytes that get populated when is extern the got, or is it something else? Yeah, I'm learning radar as well, very slowly. Very slowly. Yes, I know that feel of having the cheat sheet open and the cheat sheet's not even enough, so you gotta go Googling. Yes. Name the major functions based on the strings. I should probably ask, how is there a way that I could actually convert all those dangling functions into actual proper functions? For example, the one that has bin ping in it. Like, is there a way to actually turn these into proper functions? Like, do we just go to the top and turn it into a function somehow? There's got to be a way to actually make that actually a proper function. Press P on the first instruction. Thank you, Mongo. What did that do? Function has undefined instruction / data. So if I can't do it on the align 10, I've got to probably do it here. Okay. Oh, that's so much nicer. We can actually get the pretty grid view, like the graph view. Awesome. Then we can get cross refs to here. There's no cross refs because it's going to be jumped into in some odd way based on the dispatcher. Okay, but at least we can name it func ping. We can go through and actually turn these into real functions now. Oh, that's nice. Let's just start at the top and look for the red text and fix them up. Here we go. Yep, so this here is the, I think it was the func credits. Whatever it was, it's totally boring. This is function logout, I guess. Func. Opposite of enable, we're going to call disable. I'm sure it's not what Cisco calls it, but it'll do. This here is func exit. Oh, this is going to make life so much easier. Func troll. It's the troll shell, that one. I should call it func shell, otherwise I'm going to look func troll and not know what it is. Alrighty, my life is getting much easier. What is this doing? Func flag. Which if we can divert control to, we win. As long as it doesn't do a is logged in check. Which I don't think it does, it just goes, it can't help it go through the read or the open flag, read it, and then printf it. If we can get execution there, we're happy. Oop. We've got like a straggling jump to there, followed by an align. I'm gonna call that the first thing in the function. So this is Func Show. Yeah, it's Func Show. It's not what I wanted. Alright, we're getting there. This is the boring bit where you gotta put a cup of tea on if you don't want to watch me trudge through code. What have we got here? Help menu. What did I just zoom into? Like, did I have to define this, or is this the help menu? Yeah, it is. Like, it prints equalses and pipes and stuff. Bit of water about. Alright, that's interesting. What's that doing there? That looks like it's showing variable state. What's that doing in the apparently help? Because here we got like the header, here we got the footer, here we got the pipes that go around each help command. What's this? How do we get there? Why is it there? Like spaghetti arrows as well. That's odd. Why is... Has it gone and like interleaved two functions together? Have I done a bad thing? Can I make this not a function and go back to where and redo it? Undefined. Yes. Okay, that I should not have done that. That looks like all kinds of bad. Let's make that a function again. That looks like to me almost as though it's got two functions in one. What's it doing? That's no, it's not showing variable stuff because in a neighboring block here we've got %s no such commands. So it's probably just showing question followed by a command for more detailed. Okay. Yeah, okay, that's the %s colon %s. Okay, so this here is just the func help. Yeah. I'm satisfied that that's not got stuff in the leave with it. Never mind me. That's func help. Yeah, cool. That's that's fine. Yeah, we've got like a big loop. Like this here's deciding whether to actually print the help for a particular function or print the help menu. But otherwise, do we get like a loop? Yeah, there's at least some sort of loop going through there, and then I guess if the loop gets exhausted, we end up in no such command. And then we end up with a canary check and a return. Cool. Alright, I'm happy with that. Keep on pulling these apart. What have we got here? Yeah, so this was the login function or the enable function, which had that info leak. Func enable. So how is this info leak working? So here's the format string. This is a pointer to the string that gets interleaved in here. Stircomp doesn't compare in linear time, does it? Like, if you were good enough, that's a timing attack on the password, I think. But over the internet, you'd have to spend a lot of time actually trying to exploit that. But that's probably a bug there as well. Comparing passwords in non-linear time is bad. But yeah, EBX is what we're leaking stuff after, because there's no null byte there to terminate the printf %s thingo. So EBX, I'm guessing, is the user. Actually, no, where would it? It won't be the heap. You can't leak stuff after not the heap, BSS. You're leaking stuff on the stack. Because in BSS there is the actual enable password, this here, which is subject to the stircomp, but what you're leaking is based on EBX, which will be on the stack, I reckon. Indeed it is. And we can only leak OX20-ish bytes off the heap, stack, because the read command is being parameterized with a length of OX20. So they should be null terminating the string, but they're not. So yeah, I think that's just a stack info leak, that one. If you get the password right, then you get the integer 1 moved into the elevated area of BSS, and that makes you able to use the flag function. Cool. Alright, let's keep on moving. I think we're almost done with identifying all these functions. I think I just went to a bad place. Yeah, that's it. Alright, we've got another one here. What's this one do? Trace route. And it's another fork, then execl. So that's not going to be injectable unless we can inject a parameter to it. I think ping's pretty safe, but because ping requires a host. Really? Traceroute also requires a host, so yeah, argument injection isn't gonna give us much anyway. I reckon the traceroute and the ping stuff's safe. Because they're being execled, not systemed. If they were being systemed, we could look into command injection, but with execl we really only get argument injection, and we can only inject one, and then we can't supply the host, so we can't use either traceroute or ping with just an argument and no host. So that's boring. Gotta be almost done. So this is the set. I actually wanted to look at this. What's this jump going off to? What's this call going off to? Must be actually setting stuff. This bit of code here is used by a couple of these functions. Help, enable, ping. Oh, this is func set. I reckon the bug's in the set and the show. My gut's telling me it is. And we're done. We've found all those little function handlers. We've got a couple of unidentified functions still. Boring. Boring. This is like, I think that's the dispatcher, I'm guessing. Where it actually dispatches out to all those function handlers for all the things. But back on this before, I could have sworn there was an uninitialized variable. Which we may be able to leak with that stack leak, but probably not. What we could do is, because there's a big loop going on here, and then inside the loop, at the top of the loop, there's a stern comp comparing n bytes, where n comes from EAX and EAX comes from the strlen. The strlen is fed with the user's function, like the command they actually wanted to run. I think. What are we strlening? Strlening EBX, which comes from S2, and S2 is a local variable. WAT. Really? This function smells of either me really sucking at revenge or a bunch of uninitialized variables. Good day everyone, Jardeth. Catch you soon, eh? Yeah, cheers Mongo. Yeah, interesting, Kane. Did you see that in the password check, was it? Because like our password is, well, I mean, I think we've already seen that that's not a go, because if we go enable, we know the password is password1. It seems to say, yeah, they're actually checking the return properly to make sure it's bang on right, not not just starting with the correct. But then again, you're right, if the arguments are swapped around, then we'd be dead in the water no matter what. Yeah, this to me looks like uninitialized variables. So we're moving S2, a local variable, into EBX. Then we're Sterlening it. And we're using the output of that Sterlen in a stern comp to say how many bytes to compare between S1, which comes from our command, and S2, which is that uninitialized variable. If we can nail that stern comp, then something weird might happen based on the fact that we're not actually matching it against a valid thing to be doing. Like, that's actually worth investigating. What if we set a breakpoint on this stern comp and see what sort of thing it's comparing with? So copy that. Do I have clipboard stuff turned on? Nope. Set a breakpoint there and just see what kind of things it looks like. Anyone uses... Well, Kane, it's stern comp, not stir comp. Maybe there was a stir comp somewhere else, but this here is a stern comp in the dispatcher. But there may very well have been a stir comp as well. How do I like not suck at finding crossrefs? There we go. Okay, so in help and in enable. Okay, so it was in enable that there was a stir comp. So there's a stir comp between the ENA password and your input. And then what happens? The result gets put into arg34, then from arg34 back into EAX. Then we test it, and then we JZ down here. So we are looking for it to be exactly 0. And as Mongo said, if you're less than or greater than, you get -1 or 1. You got to be bang on to get the 0. So, yeah, no, there is. You're right. Oh, by the way, Kane, there is a 15-second delay between what I say and when people get it, so that makes for this kind of interaction really interesting. So there is a stir comp here, Kane. You reckon that's us being dicked with? Because it looks pretty sound to me. I mean, the order of it is that the first parameter is, I'm guessing S1, which is the static actual password, and we control the second argument to stir comp. Stir comp looks like this. And I'm guessing stir comp will go and compare as far as the shorter of the two strings. So as long as the password on their end is appropriately sized, we're not going to have a overread in this stir comp here. We can't control how long they make their password, and I'm sure they would make it something that's not long enough to cause a bug to be triggered and an out of bounds read to occur. And we do check to make sure it's exactly 0 down to here, which is the winning path. So I think we're safe there. All right, I'm going to take a quick 5-minute break. I'm going to fill up my water bottle. If you need to grab a beverage, grab a water, or do whatnot, then now's the time. I'll be back in about 5 minutes, and we'll pick up from here and see if we can get something happening before we get too tired and fall asleep in our keyboards. Talk to you soon. rest for the wicked. Back to it, I guess. So I'm pretty sure that this stir comp's pretty sane. The info leak is not sane. That's definitely not okay. So where to from here? We could use the leak, and I reckon there was definitely some weirdness going on in the dispatcher function with regards to uninitialized variables, but I'm gonna maybe bookmark that and come back to it later. I'm also not going to read this unless I can avoid it. I'm just going to go based on all the functionality in the funcs to go by, and this mess can be dealt with, hopefully never. I reckon it's in the set and show. Like, that seems like a very interesting bit of functionality that CTF writers often like to do weird stuff with. So I'm going to drill down on this. Looks like the set function almost looks like it's broken in two. Like, there's a call to somewhere, which looks horrible. Looks really horrible. I was going to set a breakpoint somewhere and check something out. Yeah, it was in the dispatcher. I was going to look into that. I am curious. Like this Sterling here, what gets Sterling the first time through this function? So I reckon it's an uninitialized variable, and it's bothering me. Let's go set a breakpoint here. It's in the dispatcher, so ASDF. I get a breakpoint on a Sterling for enable. How did that enable get snuck in there? It is not a uninitialized variable after all. Maybe the code sneaks off down here. Nope, that's like the peace out branch. Otherwise EBX comes from S2. Ah, S2 is not S2, it's in .data. Because that's not confusing. Thank you, Ida, for having two things named S2. Are they different colors? Yeah, they're different colors, yeah. Great, okay, so the S2 is not an uninitialized local variable. It's actually the string enable. Thank you, Ida. Appreciate that. Like, you click one and they both highlight. This is getting renamed to pointer to enable. It's a pointer, yeah? Yeah, it's a pointer. Alright, so that ain't uninitialized after all. What about down in here? That one's totally uninitialized, isn't it? Set a breakpoint on the stern comp. Nope. Nope. That's not uninitialized either. Oh, hang on, it's not S2. Yeah, sorry, that's loading up the variable from EBX, which we've decided is definitely not uninitialized after all. It's the pointer to enable. Okay, no uninitialized variables. I'm just crazy. The dispatcher, I'm hoping it doesn't have a bug in it because I don't want to trudge through this awful mess. Let's focus on the gets and the sets. The set and the show. Function. Let's start with func show because it's probably simpler. It doesn't look too bad. So what's going on with func show? Okay, so I'm guessing if we don't supply what we want shown, we come down here to probably show everything. If we did say what we want shown, we come down here just to show the one thing, or to complain that it's not set. So this function here is actually going and getting a particular thing. Get what do we want to call these? Are they variables? Are they settings? What does the docker call them? Or what is the? Let's get rid of that breakpoint. Sets a variable, shows a variable, for reasons. There's totally a bug in here. Or they're trolling the shit out of me and they're succeeding. Okay, so they call them variables, so we better call this get variable. And then based on the output of this, we can either complain that it's not set or show what it is. It's only called in one place, only there. Over here we must just kind of walk a list somewhere. So where is this list of things? So there's a pointer in BSS to it somewhere. This location in BSS is referenced from the getVariable function, the funcShow function, and a few other places in this particular sub. This sub here is referenced from funcSet. Okay, so just the pointer to the head of a list or something. Let's dump this in GDB and see what it is at the beginning of execution. A whole bunch of null pointers and then OX24 and some null pointers. Let's set something. Set food to bar. So let's set A to B so we can recognize them. Okay, we've got 2 pointers here now. Is this 24 important? How many variables can we set? It looks like they get kind of stored here. Let's continue. Let's set CCCC to DDDD. Break. Not what I expected. Examine 4 strings there. 4 strings there. How do you actually examine pointers? So I'm lazy. I'm gonna normally do. Let's do telly. Let's telly there. Huh. That was kind of unclean because I set the wrong thing. Let's start again. Let's set BBBB. That telly again. Okay. How's this working? Let's go and clear the first one out. Set another one. Okay, so this looks like it's some sort of so at this location in memory we've got pointed to a string, a pointed to a string, then a pointed to a string, followed by pointed to a string. Like a linked list, when if we remove stuff, then we can actually fill in the gaps. So it's last in, first out in terms of an allocation order for filling in gaps. We've got pointed to string, pointed to the next record. If we go there, we've got pointer string, then a null pointer to say it's the end of the list. Okay, what if we break the list? Start again. So we set AAA to BB, AAA to BBBB. CCCC to DDDD, set EEE to FFFF. We do a show. There's 3 there. Now what if we clear the middle one? Oh, we still get the whole lot. What does that look like? Telly. Really? Really, Peta? You gonna do this to me now? Hang on. I copied and... Sorry, I mucked something up. That was my bad. Let's telly there. Nope, let's telly OX there. Okay. So where are we? In BSS? Yeah, we're in BSS. So within BSS there's pointer. What? Is that on the heap? 83. FD. Yup. Okay, so within BSS we've got a pointer to the heap, a pointer to the heap, and then a pointer fair ways off in the heap to D4, B0 somewhere else on the heap. Okay. What else is near here on the heap? Can we allocate enough stuff using set to actually go and destroy the ENA password? Maybe. In GDB, if we grab this and we examine one string there, or is it a pointer? No, the string itself is there. So we may be able to overwrite the password with a pointer into the heap. But what's that going to give us? If we can get that far, if there's nothing stopping us from setting it. Set AB, set BB, set CB. This is going to take a while, but okay, no, it looks like we can't actually set these within BSS. Looks like you can only set kind of the first element, and then off then it goes into like a linked list land almost. Big telly there. Telly there for 100. Then yeah, we can see our other records down here. Okay. So it's a linked list of sorts, I think. I think that's a linked list. Do I have any certifications? I've got OSCP and OSCE. Am I programming in it? I'm not programming in assembly. I'm doing a binary pwnable where I need to understand the assembly that makes up the program and then write an exploit that exploits it. Can you crack it? Not sure if you're referring to anything there, but we'll see how we can go. And indeed, the Wizzy, I am a certified 10x full stack hacker, 100%, according to the University of Stupid Twitter biographies. So there's a list out here in the heap. So what does this mean for us? How can we corrupt this list or otherwise cause trouble for the establishment? The strings themselves, I think, are actually stored. Yeah. Are these useful things to overwrite? Let's clean this up a bit. Let's go and telly the BSS again. This here. And then telly. Let's go and telly from the A's. You don't think I want? Okay. All right. Thank you, Mongo. That's probably a well-timed hint to stop digging down this rabbit hole. No, I think you were bang on with that. So, Mongo, do you think I should not look there at all? Like, I'm guessing the bug's not there. I'm guessing I may need to eventually use it, maybe. Don't answer that question, because I will take your word to mean the bug's not there, but I'll always remember it's up our sleeve later on for setting up something somewhere to then be somethinged with. For the meantime, I will abandon set and show. Thank you, Mongo. Otherwise, we would have been here all night and I would have gone to bed upset. So, appreciated. Alright, so if it's not set and show, what else could it be? What else could it be? We know it's not Shell because Shell's a horrible troll. I'm pretty sure I shouldn't say it's not Shell because otherwise Mongo's going to be sitting there going. I don't think it's going to be ping or trace route. The enable info leak was really interesting, but it's only going to really leak the stack. What could be on the stack that's worth leaking? If we can set up the right stack frame in the right spot, then leak something, will there be anything useful there? I don't think so. Let's look at ENA password. It's referenced from read password file and func enable. So I don't think we're going to end up with the password being leaked onto the stack anywhere. I don't think. Now we f-read straight into it. What else could the info leak give us? So here's that enable function that actually sets the privilege level if we get the password correct. Here's the stir comp. I'm just shooting in the dark now until I find something that's worth digging into. So I'm just going to stumble around for a bit and we'll see where we end up, hey? Indeed I do. Got the info leak. So I would have gone to bed slightly happy that we found an info leak and not known what to do with it. Can we? No, we probably can't leak a canary. Not that we've got a stack buffer overflow to do anything with the canary with just yet, but we could possibly leak a canary. What else could we do with an info leak?
Everything changes.
Let's set a breakpoint on this call to printf to see what we're leaking. Let's tell you from there. I think we can leak OX20-ish bytes. Because we get the ability to read in 20 bytes. So we could read in a full 20 bytes and then we get however many bytes are left until the next null. OX20. Which takes us from the beginning of 38 to 58. So we can read like... Well, there's a null byte there, so we can read all of this. Including whatever was there. Of course, if we cause some other stack frames to be thrown before we do the enable, we can have some influence over what garbage data is within this variable here, because this really is space for the password being read in. So we can somewhat influence what sort of data gets left behind for us to pick up using this info leak. So what functions could leave interesting stuff on the stack there? Basically anything around the time of the... Because we're going to have a stack frame for the dispatcher, then atop that will be thrown a stack frame for the function we're calling. Mind you, there could be stuff before or after the actual dispatching by the dispatcher that throw stack frames that make sure it'll always be something static. Because where is the jump or call in here? Oh, I called him Malik in the dispatcher. Lovely. That's just great. Okay, so here's the indirect call. This is what actually dispatches. And we're probably going to have a call before we get the chance to loop again, because yeah, we finished this call here, which could be something that we cause to be called, which would be interesting. Then we go to here. We might loop, we might not. Probably will loop. Is there a loop that wraps the dispatcher? Yes, there is. How's it going, Energy Live and X4SP? What language is this? It depends. If we're looking at this here, this is the Python exploit I've been writing. This here is a debugger, which is just showing the current contents of memory. This here is assembly. Indeed, it's Intel assembly. So we're probably going to have stuff being called in here that's going to... Because here's our indirect call, was down here somewhere. Here it is. Here's the call. I guess this might loop, it might not. But even if it does loop, it's looping all the way to the top, and there will be a call in here that will ensure that turds are put on the stack which means that we don't have that much influence over what is in the stack frame of the enable function that could leak anything that we want to make sure we have control over. I think no matter what, we're going to get stack contents that look something like this. And we've got a pointer into what libc. F763. Yeah, so we've got pointers into libc. We've got pointers onto the stack. Is that a canary? Is that like a... Is that the canary? Is that a special canary or like a debug canary? Just looks kind of special debuggery. That null byte there would stop us leaking it anyway. I think. Does that change across invocations? I think I had to set a... You know what? Let's actually code this breakpoint in. Func enable. Is that a canary? And does libc or whoever's responsible for making canaries always end them with a null byte so that you can't leak them? Jerks. Let me just try something real quick. Enable OX20 is 32. 1, 2, 3, 4, 5, 6, 7, 8. Oh, we're off by a bit anyway. Can we get more than 32 A's in there? 1, 2, whoops. Do that, then a B. Yeah, and the B is an invalid command. So we can't leak as far as this, which looks like it could be a canary. Enable, enter. Let's go and tally that. Oh, we got some leftover A's there, hey? I'm just going to go and pinch a copy of this and then throw another function and see if it changes. Question mark credits, set that to that, show Mabel. Okay, so some stuff shines through here, maybe. Otherwise, yeah, the frame's the exact same. The exact same. Apart from, there might be a hole here that some stuff can show through because there's variables not being used in whatever stack frame leaves stuff here. So we may have a small window that we can leak stuff within. What could we leak anyway? Am I using any plugins in IDA? No. No, I'm not. I'm just using straight up vanilla IDA. Hello there, Matasaurus. Good to have you around. Just gonna, just for giggles, try this real quick. Yeah, I mean, I was thinking if bash shone through here, then we'd have some confirmation of something, but nah. We can't even get to the flag function if we're not privileged, I don't think. Yeah, invalid command. I mean, what would we want to leak anyway? We'd really just want to leak the enable password. The flag's not actually stored anywhere inside the memory space of the program. We tried doing a read being the very first thing we do. We've got a pipe there, which is probably from the, maybe from the, probably not from the menu printing. Yeah, I just don't know if this is going to be of any use to us. Just yet. Maybe down the track, but I think we need another bug. I don't have to go through dispatcher to find one in there. Where else? What else? What haven't we looked at yet? How do we get to this disable one? Let's go log in and see what that is. Help if we actually logged in. Okay, so there is a disable option once we're logged in. Did we get anything else new? We only got disable and flag. Curious as to what all these are. If anyone hasn't seen the Tracer T video on YouTube, they have to watch it, and that's a direct poke at the Tracer T video. Are there any hidden commands? We should probably look for these strings and see if there's other hidden commands. I don't think there will be because we haven't found any other interesting functions. Huh. No cross-refs. Interesting. You know you're desperate when you're just reading strings. Nothing interesting. Hello, what's this? Ah, no, not a string. Dispatcher. Blech. Okay, so this here looks like it's the is logged on check being done by the dispatcher. EBP plus 8, hey. Where is EBP plus 8 being set? EBP is not really being used at all. So where's EBP being set then? Yeah, so this is curious. Why? I shouldn't say why. How is the dispatcher caring about is elevated in what cases, and how is it comparing to what to see if what should happen? And can we control what's at EBP plus 8 to make stuff that normally requires elevation not require elevation? What's being freed? Oh, it's a local variable called pointer. Can we tie multiple commands together? It's only comparing the beginning of the string. So semicolon's not special. How's it going? As you Rick, up to DEFCON pwnable challenge, like it's a binary CTF hacking type thing that we're doing. You're horrible, Mongo. You're good, but you're horrible. The software I'm working in is mostly IDA. I've mostly been in IDA the last 20 minutes or so, last couple of hours actually. IDA's it's the interactive disassembler. It's for reverse engineering software. So, okay, if you're a programmer, I can give you the 2-minute intro to what IDA is. So IDA is generally used for disassembling compiled programs. So you're a programmer, you'd be well aware, you write stuff in C, you put it through a compiler, and out pops a executable. On Windows it's a PE, like a .exe. On Linux it's a not anything, it's an ELF file, full of compiled machine code. So what a disassembler does is it takes that compiled machine code and then analyzes it and breaks it apart. And it used to look like this here, but it breaks it apart into the assembly, so it takes it up a layer of abstraction and makes it only just barely understandable. It's much better than reading that, but it means that your nice high-level language C code now looks like a bunch of assembly instructions. I mean, computers, contrary to popular belief, do not execute assembly. They do not execute MOV, tab, EAX, comma space, left square bracket. They execute binary code, ones and zeros, which is represented as hexadecimal. When we want to look at this and understand what's happening inside a compiled program, we take it up a level to the assembly, which is a human readable version of machine code, and it represents the operations and the things that are being done with opcodes such as MOV and operands such as EAX and the address or the dereferenced thing at ESP plus OX3C plus a local variable named PTR. Slightly easier to read than binary garbage. So that's where it probably fits into your world as a programmer. What I'm doing is I'm taking compiled machine code binaries and then trying to make sense of the mechanics of them. So hopefully that helps orient you with what we're looking at and why we're looking at it. And we're looking for software bugs. We don't have access to the source code to find out what the bug was from the source code. I don't have the expensive decompiler license for either, so I've got to make do with looking at the assembly, which is good practice for learning assembly. A decompiler license would be nice, but I enjoy, to some extent of the word enjoy, trying to understand assembly. I don't enjoy it when it's a horrible function looking like this, though. And Mongo's telling me that I should focus on the info leak. Yeah, it's kind of like variables. Like, for example, when it refers to something like this here, that's a local variable, just like you'd have a local variable inside your function. And it's how the computer accesses it based on something that's stored on the machine's stack. But much more than that, it's all the mechanics around how the function, which was a series of ifs, thens, case statements, calls, additions, subtractions, multiplications, how they actually get turned into machine operations that a CPU can perform for you. So it's a little bit of the data, like variables and how they're used, as well as all of the mechanics around how they're used. And Mongo's telling me I should go back to the info leak instead of playing. It's probably instead of playing with this is elevated stuff deep in the bowels of Dispatcher. Back to the info leak we go. Back to pwnable. Man, if it weren't for Mongo, I'd still be hammering on that set and show stuff. So just for giggles, I didn't want to authenticate there. We can try stuff like enable. Oh no, it'll be in a child stack frame. Never mind. We can go and pollute this child stack frame, but parent, sorry, but it won't be useful. Yeah, cheers. Well, thanks for the kind words. I generally stream twice a week. I'm streaming once a week. This week I'm not streaming on Sunday. But generally Wednesday night, Sunday night, Australian time, I go through a bunch of different, Brisbane time, East Coast Australia. I go through a bunch of stuff like pwnables and sometimes do web app stuff. Sometimes I just rant and rave about PGP for about 3 hours and go through more theory stuff. But I tend to focus on a lot of binary pwnables and let them kick my ass up and down the street while Mongo throws me tips to keep me on track. But I enjoy, to an extent of the word enjoy, failing on stream and proving the fact that it's not all winning. That you only get good by trying hard, and even people who stand up on stage at conferences and do 45-minute conference talks about how they wanted to do a thing, so they did a thing, and this is how they did the thing, and then they won. They don't talk about all the things that they wanted to achieve and never achieved, or all the different ways they thought about doing something that ended up being dead ends. That can be embarrassing sometimes, and sometimes it doesn't fit into 45 minutes. So I think it's hopefully for people a bit refreshing to see someone show the process, the pain, the tears, and the dead ends, and the lack of achievement that often isn't really spoken of in the security industry. We're in an industry of rock stars and celebrities, and we look up to people, and yeah, some people always win because they're just amazing, but most people don't always win. So that's my excuse for sucking, is what I'm trying to say. What's this info leak gonna give us? Because, I mean, it's mostly going to be polluted by the stuff that dispatcher calls. There may be some... I think I did see there was a bit of a gap. Like, if we do continue ENA enable bunch of A's, probably only want exactly 32 of them. 1, 2, 3, 4, 5, 6, 7, 8. Paste, paste, paste. Continue. And then enable, empty string. Now if we go and telly that for 12, then we can see that there, we've got some of our arrays still there. But for the most part, this part of the stack's been rewritten with the stuff that we're used to seeing. We can fill that with A's, forcing a leak of that, but we're going to get killed by this null byte because little endiant's going to appear first. But these are, I think they're just really pollution from other functions called by the dispatcher, sorry. And this here is an opportunity for some other stuff to kind of shine through a bit. But what can we cause to put something there? And, I mean, what would be really nice is if we could cause dispatcher to do a much tighter loop, for example, by executing 2 things in a row. Like, is there a way for it to... Here's the call. Is there another indirect call in here that I'm missing? Call to stir dupe. Call to malloc. Stern compet sterlen. So this is the only indirect call. Can we make this loop? No, it's going to loop up before the sterlen. So we can't do, for example, 2 things in succession without going back all the way up to sterlen. And when we go all the way back up to sterlen, there's going to be those 3 or 4 calls again, which cause stack pollution, which limit our ability to leak stuff from previous stack frames. I think it's just entertaining to watch Justin hurt. I don't suck at it. I'm not good at it, but I don't suck at it. Thank you, Mongo. I really appreciate that. I still think you should stream as well, Mongo. Maybe we could do like a crossover stream. You, me, and OJ beat up on something. If you don't want to jump in Discord with us, then you can tap away and type away. But I think it'd be cool to have the 3 of us maybe host something sometime. See if we can all find something we want to work on together and explain things as we all do with our own unique way of approaching it. If you'd be keen, Mongo, let's make that happen. And if you don't want to have your face up, or if you don't want to talk, that's cool. We can work something else out. So yeah, we can't make this. There is going to be pollution. So what else could we make shine in that little window of leak we get? What else? What could possibly be getting put on the stack? Mongo's. I think Mongo's telling me to look at this right now. If there was another bug that I'd need to find first and then fall back on the info leak in order to exploit, I don't think he'd be pushing me towards this. I think this has got to be basically usable straight away. We've just got to find not another bug, but just a way to make something appear on the stack in that location for it to be leaked. Maybe. That's your cue, Mongo, to tell me if I need to find another bug first. If you say nothing, I'll assume that I should just keep on looking where I'm looking in the area of the leak itself and the way that I could cause something interesting to be put in the location being leaked. I'm going to go back to that leak and have a look at that. pwnable. Hang on, what's going on here? What's this? Can you supply the password? Hang on. Alright, we can leak the heap as well. I've just spotted that. I saw this stern copy, I'm like, oh, stern copy in the leak function sounds good. Is it the heap? FFC1. It's gotta be the heap, yeah. Nope. The stack. Hold up, hang on. Stack, not heap. We can leak a lot more than OX 20 bytes. Right, I saw this stern copy. I'm like, her, and it will do a stern copy in some case based on a conditional branch. Instead of asking you for the password, that made me go, hang on. Does that mean we've got two options where we can do enable, be asked for the password, give it a password of AAAA, and then have the leak trigger, or can we actually kind of put the password on the command line? So that it, I guess, gets passed along by the dispatcher. And the answer is yes. We can. Instead of being asked for the password, we can supply it via the dispatcher. Does this mean we're leaking what? Does it mean that instead of within the pwnable stack frame, if instead of the pwnable stack frame, does it mean we're leaking stuff inside the dispatcher stack frame? If we could just do enable AAAA, then we're leaking from here onwards. If we do it here, then we're leaking from here onwards. Same location. Hang on, there's a stern copy. How many bytes? 20 bytes. Okay, no, we can't leak more. We're back to just 20 bytes. And is stern copy gonna null terminate it? Yeah. Yeah, the stern copy is gonna null terminate it as well. So that's actually, I think, seeming like the worst of the two options. I think we're better off going down to the read command. What is this going to do? Well, if we do enable space, yeah. No, we can't cause a stern copy of garbage data from the parent stack frame. Still could be interesting. Because we don't have a good handle on the way stuff is being dispatched, and at the time of the dispatch, what is in ESI. Here's the call. So ESI is actually just a counter.
I'm running away from this pain. I'm trying to find a new way where the sun's shining down on my face. I'm running away. You're in a toxic relationship.
Okay, so here's the function pointer. Yeah, I just kind of traced that back. It was at the address of the string plus OX10. So there's the function pointer in .data. ESI is a counter. ESI is a counter at the time of the dispatch. Func enable. Back to func enable. Don't worry, Mongo. I wasn't going to stray for long. It can't be a counter because we're dereferencing it. But it's based on what's in ESI that then gets derefed and put into EAX, and then based on the output of the test. It's non-zero, then we go down to the stern copy. I mean, can we cause something interesting to have been left in ESI? For example, pointed to the password. Might have EBI be a pointer to the password, or yeah. Yeah. Which would cause it to be stern copied and would actually win the... it's not the leak. Mongo wants me to look at the leak, but that could be an auth bypass. If we could actually have ESI be set to the point of the password at the time of this being invoked, would be sweet because the auth would win and we'd be logged in. But no, Mongo wants me looking at the info leak. Maybe he wanted me looking at... What did he want me looking at? Okay. Stern copy has a fun quirk. Alright, maybe the stern copy was interesting. There's a stern copy, not stern comp, yeah. Like the non-overlapping stuff. Right, okay. Cool. I gotcha. I got you. We're still doing OX20. I don't know if that gives us anything more than the read of OX20 bytes was giving us. One way to find out. 2 fun quirks. Was it the non-overlapping stuff and then the null byte stuff? See, I wasn't thinking that the overlapping stuff was going to be useful to us, but the null byte is. But I don't know what it gives us over this code here. As I said, one way to find out. Enable 1, 2, 3, 4, 5, 6, 7, 8. Let's go tally that for 12. Let's continue. Let's try an extra enable that B. Nope, don't continue. Yeah, so I'll lose the B. I don't know if that gives us anything because is that just OX1? I think it's just, yeah, octal OX1 basically. Then we get a 1. And the read will, the info leak will stop there. Like we might get the 1, but yeah. So we get the 4 1s. We get the 4 1 4 1 4 1 4 1, and then okay, this here is that 1 there. We get the 1, and then the null bytes are gonna be the printf terminator. So back to the man page. At most n bytes of source are copied. If there's no null byte among the first n bytes of source, the string placed in dest will not be null terminated. The length of source is less than n, stern copy will then go and null the shit out of everything else. Yeah, boring. Annoying. Is it boring? Is it annoying? Yeah, I mean, OX20 is what we're reading either way, so that's we're doing it to source, and source is how big? Nope, we're doing it to EBX, which is dest, and dest is hang on. My brain's hurting. Hang on. Destination is at OX18. arg8 is at OXC. So we can overwrite arg8. Which is only used over here anyway. So So that just seems like a fair enough optimization. Can also overwrite N. Can we like overwrite the arguments to stern copy halfway through the stern copy? No, because that B didn't make it through, so it doesn't really seem like it's going to give us an out of bounds right or anything like that. So if we're stern copying to ESP plus dest, and dest is OX18. Dest is in the parent. Dest, is that in the parent's frame? Not our frame? Because that's a positive number, and it's doing the stern copy to ESP plus destination, so it's actually writing to the parent stack frame. Yeah, Mongo has got that. Yeah, Linux and I think OS 10 as well. Yeah, most people get it for Windows though. I think it's for I think it's better supported under Windows. I think it might be less buggy under Windows, and I think there might be more plugins under Windows. And IDA is not free either, so if you're gonna, and you have to buy it per platform. So I made the decision to buy it for Windows, just because I was under the impression it was better supported. Is it local? You reckon, Volko? Even though it's plus there, it's not got a negative here. It is. What was the trick to see the stack, Mongo? There was a thing I could do to actually look at the stack. Yeah, okay, so it is a local variable. I was looking for a plus or a minus or something and thinking it must have been in the parent, but yeah, it must be a local variable. Thanks for that, Volko. Double click a variable name such as dest. Yep, wicked. Thank you. There's a quirk in stern copy. And I pointed out the fact that you can't have overlapping region. He said, well, there's two. And, right, okay, so EBP plus is local, EBP minus. Yeah, right, Volko, this doesn't have an EBP though, it's all just based off ESP. But I guess the same thing carries along that, yeah, plus is local, minus is argument. But the stack goes down, which is what was confusing me. I thought, it must be the other way around. Cool. So I said to Mongo that there's one quirk with Stern Copy, and that's that you can't have overlapping regions. And Mongo goes, well, there's two. And then Mongo said, well, yes, it's the fact that Stern Copy won't null terminate the string if you give it exactly OX20 characters to work with. But that doesn't seem to really get us any more leverage over the leak, because we just end up leaking number one. USA number one. So bunch of zeros there from where Stern Copy actually nulled it out. Dest is a local variable, then it's at minus 18 hex from ESP, right? Because the stack grows... Oh, hang on. No, because there's no EBP, it will be plus from ESP. It'll be plus from ESP, but minus from EBP. Right, okay, I've got my directions sorted now. I know exactly why it's presenting the way it's presenting it, and why I had my pluses and minuses the wrong way around. So at ESP plus 18, going down the stack, there is this. At ESP plus 38, there's something else. So there's no buffer overrun here or here. Cool. Okay. It seems like arg34 is what is arg34. The stir comp. Ah, okay, I got it. I'm stupid, but I got it. Yep. We can leak the output of stir comp. We can. Kane was right all along. There was something fucky with the stir comp. We can leak whether we were less than or greater than the password. And we can attack the password. And Kane's still here as well. I thought you were gone, Kane. What is the number one? Where does it come from? I thought Kane left as well. No, he just stood in the shadows to wait for Justin to actually wake up to the fact that stir comp was fucky. Alright, the info leak lets us leak the response of the stir comp. Kane did leave his multitasking, his ears were burning, he knew that I was on his, I was slowly catching up to where he was at. Alright, we can attack it. Okay, that's cool. Now, I haven't done this before, I haven't actually done I'm guessing you'd call it a binary attack on the output of a stir comp. So that's kind of cool. This is going to be interesting. This will be fun. Let's how's this gonna work? How are we gonna do this? So we know the first character of the password is P. So if we go enable, do we want to do it here or? Yeah, let's do it here. let's do the letter before lowercase p. 1, 2, 3. What are we leaking? We're leaking the number 1. If we do a bunch of p's, are we going to get 1 or -1? If we do a bunch of q's, we're going to get 1 or -1. This is kind of going to become our little indicator as to whether the password we're guessing, which is a whole bunch of lowercase o's, is less than or greater than the password, and we can kind of we're going to have to send lowercase o, then a bunch of byte number 1. We can't send nulls, and hope that there's no byte in the password that's actually number 1, and that's going to fuck with us. We could cope with that if yeah, we could work around that. All right, so we've got number 1 for a whole bunch of o's. Enable PPPP. We've got -1 for a whole bunch of p's, which has told us that we've just ticked over the correct character. All right, let's code this up. Let's do some stuff. Let's see what we can do. T dot send line O times 32. Actually, let's go O plus hex 01 times 31. Let's t.recv until let's eat this banner. New line $. Is there a space there? Yeah, there's a space there. And then send the O's and then go interactive and see what we get back. Derp. Enable O plus that. Okay. T.log.info. Let's go and pull down a line. Let's just pull down a line and log it. Pwn.log.info, that'd help. Oh, we only got an O. We didn't get like this 41 times 31. I'm doing something silly. Alright, so we got that. Let's go P. Should get -1 back now. Print t.recv line .encode hex. See if we can just spot this -1 coming down the wire. That's +1. Do we need the O for -1? Hang on, this needs to be O. There's the 1. Let's make this P times 32. We should get a -1 back. Yeah, there's our -1 coming back. Okay, so we need to instead of sending a bunch of -1 hex 1s, let's send O plus hex FF times 31. See if this gets the equality thingo working for us. So that was we got back 1, we can see the number 1 there. we send P, then a whole bunch of FFs. Do we go back -1? Kind of hard to tell. That could have been -1 there as well, actually, but it looks like we get back more output. So there was the 6F, there's the 70. Yeah, I think we're getting back -1 there. Well, we're not getting back 1 at least, so yeah, that's going to be -1. Okay, so we need to pad with FFs, not pad with 0-1s. Now, it will let us deduce each character. We should probably be grown-ups and do a binary search. I picked a good password as well because there's double S in it, which is going to potentially test. I reckon that's the biggest corner case for a binary search like this, where you kind of have the less than or greater than, and you're trying to go position by position. So the fact that there's a double S in there is actually a good good test case. So that's how we eat the prompt, and that's I think to eat the prompt we just def eat prompt. Just eat up until new line $space and hope that new line $space never comes up anywhere else. That's actually a really bad thing to probably be assuming. Yeah, I'm just going to YOLO the eating of the prompt and just do that. If we have problems, I know where I'm going to come back and actually be a grown-up and do things properly. But the lazy way is just to eat until we get a new line $space, and that way we can kind of consume and eat up all the prompts that might get thrown back at us. Actually, we probably don't really need it apart from the first time we do it. Just going to throw a log line so I know when I'm doing it. So we eat the line, eat the prompt. You know what? Now that we know what we're doing, I'm going to take a quick 2-minute break, fill my water bottle, and we'll come back. It's getting late, but those who are hardcore will stay with us. When we get back after this short break, we'll be, I don't know, failing in an exploit in weird and wonderful ways and finding new things to do wrong. So catch you in a minute. Alrighty, we're back. Thank you, Kane, for picking up on the interesting stir comp truly before I thought to look at it. What I find hilarious is that, I think one of the first things I said when I looked at this function was, oh look, they're doing a stir comp. Stir comp doesn't run in constant time. You could do a timing attack on it, herp, and then just moved on with life and didn't think to look at the fact that you can totally leak the output of stir comp, so you don't even need to do like crazy timing attacks. You can just basically binary attack it. Fuck my life. Alright, let's okay, so we got like a home row. Nope, caps lock. Yeah, caps lock. Okay, we got a prompt eater function. We're gonna eat the prompt once. I don't think we need to eat the prompt after that, because I think I'm just gonna cheat and do like rect v until enable I'm just gonna do like a rect v until isn't space, or rect v until nope dot space space the password isn't space, and then just cut off 32 characters and then read my positive or negative number. I think is what I'm gonna do. And screw eating prompts after we've done it for the first time. In fact, we probably don't even need to do it the first time. We could probably just live life with rect v until, being the lazy people we are. Let's get rid of the eat prompt. One less thing to worry about. Alright, so let's actually binary attack this thing. What are we gonna do? Alright, so we've got a function to do the hard work for us. Get rid of those. It's a totally needless function. It's a totally needless function. Alright, so we're doing the thing. I'm just prolonging the inevitable of having to actually do things. We're going to how are we going to do this? What does the output look like when we win? Oop, I copied some bad characters there. Okay, so when we get back authentication successful, we know that what if we actually will we know, because we'll have like a whole bunch of padding bullshit on the end. Okay, cool. Right on. As long as we how will we know when we've won? Halfway through a binary attack, so we don't keep on trying to higher lower things when we've already got the password. I guess it'll be maybe even if we've got a whole bunch of trailing FFs, we'll just get the success message even with the trailing FFs on there. Yeah, I think we will. So when we get this back, we know that the binary attack can stop because we're authenticated, and then we'll just do a t.interactive and drop to a shell, and then the person can get the flag. We'll print the password out for good measure. So we don't need to worry about the terminal case kind of trapping us in an unsuccessful binary attack moving forward. We should just win. We should just get authentication successful once we got the right password. Or we'll find out what the 32 character long password is and go, well, we're done with that. Right, so how are we going to structure this looping attack? So we'll just have like an empty string, and we'll just kind of append to it as we successfully discover characters. And then prepend our attack with that, and then pad it out. Yep, cool, we'll do that. Password, we'll start with an empty string. So because we know this up to 32, the password can be up to OX 20 bytes long. So for iron range, up to the length of the password, do t.sendLine something like password plus candidate password equals empty list. Append the password. The character that we're up to. Should probably just go from OX1 through to OX FF doesn't really make much sense, but it's off by 1 with a range, so we'll go FF. So I'm going to append the password, append the character I, candidate password dot append. So you know what, we'll make this a string. Even though appending to strings is slow in Python, it's going to make life easier. I'm going to go hex ff times max password length minus the length of candidate password. Let's make sure this looks sane so far. Oh yeah, because it's not actually creating password because we haven't actually appended any successful things yet. So the candidate password is the password so far, plus the character we're guessing. We should probably actually do a binary attack, not just try every single character. Yeah, I did promise I'd do a binary attack, not just loop through all the characters. How do you binary attack in Python? So you're going to start off by picking a midpoint between OX1 and OXFF. Which is 128, which sounds reasonable. And you'll find out whether the password is higher or lower. Binary attack's kind of going to suck because we don't get a yes when we get it correct. We just get a, okay, you've kind of gone greater than rather than less than. So it's a state change as you kind of move up the range. So we're going to need to binary attack, and we may end up in a worst case scenario where we actually kind of binary attack it and then end up just drifting towards the correct one, which is still quicker. Do we want to binary attack, or do we want to be lazy and just walk through the whole range? It is getting kind of late. I'm going to be lazy. We'll save the binary attack for... I say we'll save for another time, but we probably... If we blast through this, we might revisit and see if we can tweak this, but I'm going to probably want to go to bed. So let's just bugger it and just blaze through the whole range and then wait for it to tip over into greater than land. So we're going to pad it out with FFs, and then we're going to t.sendLine, enable plus candidate password. As long as we don't do new line, because new line falls in that range there. I mean, we could limit this down to the ASCII range, but we should probably actually do all the bytes, because all the bytes are probably allowed to be used in passwords. How do you exclude something from a range? Is there a quick way? Because normally I just have like a nested if, but that feels ugly. That looks good. Yeah, that skipped over 10. Looks to be the goods. So that'll skip the new line. Then we send enable space candidate password as a line, and then we see what we get back, which is going to look like either nope or the password isn't. We probably should eat the prompts. Okay, that's waiting for something and blocking. Let's get rid of that breakpoint. Is that actually blocking? Yep. Enable a why is that blocking? Ah, because we're maybe not eating that. Why is this? Why are we blocking? Ah, misleading new line. Dollar space, that's so asking for trouble. Let's see how we go. That looks better. Okay, so it's like blazing through characters now. So response equals t.recv line. If response dot is it starts with in Python. Yeah, so if response dot starts with authentication successful. Then we want to break out of both these for loops. How do you break out of two for loops at once? Oh yeah, that'd be smart. Actually wrap this in a function. So if the response starts with authentication successful, we just return the password. Otherwise, we print t dot print response dot split. Can you split on isn't space 1? Not what I expected to see. Get rid of this. Oh, we need to actually call a function. Get password. Yep, so it looks like we're just returning all that data there. So print response.split isn't number one from, do we go 32 onwards? Like if we, no, 32, we fill this with A, just for a second. String index out of range. Really? Why is that 32 out of range? Yeah, the over the wire stuff's pretty good, indeed. As well as that, if you're looking for binary stuff, by the same guy that does Pentester Lab, there's exploit exercises. If you're interested in stuff like Matt Keir, if you're interested in binary stuff, then exploit exercises has 3 different boot CDs that have some really cool stuff, and they walk you through the concepts of binary exploitation really quite nicely. As well as that, there's a web-based one called Micro Corruption that I was a huge fan of. I did a couple of streams on it about a month or 2 ago. I'm a big fan of Micro Corruption. It really gently introduces the idea of binary exploitation, and the cool thing about it is it's not Intel, so it introduces you to it in a neutral environment, stops you from picking up Intel habits to start with. Increment if -4, yeah, cheers, Kane. Good to be back, Mongo. Probably just missed on out on a whole bunch of embarrassing me trying to actually attack this thing. Why is this 32 out of range? Oh, it's only sometimes out of range. So if we, yeah, okay, cool. I get it now. Trying 0, call is it hash 08x. Spaces are killing it as well. Cool, okay. If x not in, OX20 or new line. Yeah, cool. Now we're getting back FF or 01, and it's ticking over to FF on hex 71, which is lowercase p, I think. I'm just making shit up, actually. Hex 71, lowercase q. Right, so when it ticks over the valid character, then it goes to -1. Okay, so if response.split isn't number 1, number 32 equals hex ff, then password plus equals the character at I -1, break. Let's go and bring this eat prompt up a bit to just after the recv line. print password so far plus password. I'm going to just shut pwnTools up and get rid of all this log spam. Get rid of that, get rid of that. Hey, there we go. That's starting to look like it's making some sense. Kind of fell over a bit at the end there, but we're doing something along the right track. So what we're doing is for every single possible character, because we know that the password can be up to OX20 characters long. Actually, that OX20 needs to be taken out and replaced with max password len. We're doing, for every possible character, actually, we've doubled up on variables here. For I, for password char, for, I'll leave that as I, because I already refer to it in here. So for the password char, and we don't use this is just a way of looping for the correct number of things, and if we get to the end, then we know something's kind of gone wrong. Something's gone wrong, we've fallen out of the loop. And then just kind of return something. Be interesting to kind of look into the cases in which this code would be reached, but it shouldn't be reached if the code works. Not falling out of the loop, we've finished the loop. Really, we should actually determine the password before this loop here finishes. So for each character, we do for each kind of possible character, it can be in the range of bytes, except for space, and new line, and null byte. In fact, let's go and tidy this up. Let's put null byte in here. So for every character except for FF as well, we've got a bit of an off by one with range going on here, but FF we use as the padding character anyway, so bugger that. For every character it could be, we build a candidate password, which is based on the password discovered so far. We append on this new character, or the character as per the number that this is, and then just kind of pad it out with, not 41s, with FFs. That was just a debug thing that I should have taken out by now. And we go and send that away, padded with all those FFs. We send it away using enable space, then the candidate password. We get back a response, which should include a leak of whether stircomp, or was it sterncomp? I think it was stircomp, decided that our candidate password was less than or greater than the actual password. Then we just eat the prompt to kind of clean up shop a bit and get rid of some new line dollars. So they're just dollar spaces. We don't need this. We don't need that at all, actually. Yeah, we do, because we check to see if the response starts with authentication successful. If it does, then we return the password because we've won. Print found the password. Plus password. I should be using pwn.log.info for these, but I'm just being lazy tonight. We return the password we found. Otherwise, we kind of split the response on the word isn't, and then go and get that first byte of the stuff we leaked. If it's OXFF, which is a -1, which means we've kind of just ticked over another character of the password, then we append to the password that we've stolen so far the character that we just ticked over, because that's what the actual password character is. And we kind of print a success thing, password so far plus password. And then we break, and if we get down to here, then we kind of say, whoops, we shouldn't be down here, something's gone wrong. So let's see if that works. Password so far, it should be 01. So now that we've changed this from 41 to FF, we now need to swap the logic around down here. Actually, no, I don't think we do. We just need to get rid of this -1. There we go. Something's gone wrong, we've finished the loop. But we did find the password. Interesting. So we never actually got back authentication successful. We never got back. Oh, because we actually need to null terminate the string we get back. I wonder if in production this service actually had a null terminated password. Actually, no. No. You need to null terminate the password yourself. Unless we do enable space password 1. Okay, it works there. Maybe after we leak each character, we just go and do enable space password, enable space what the password is so far, and then check this. If we don't get back a success, we then loop and continue getting characters until this comes back successful. That's what I think we should do. So we don't need the response.starts with anymore. No, we don't. But what we should do is, if we've got this FF, which means we've gotten somewhere, we print the password so far as the password, then we just try the password. T.sendLine enable plus password, and then if t.recv line dot starts with authentication successful, print and the password. It is plus password. Return password. What we should do is just to clean this up, response equals t.recv line. That's a response there, and we should just eat the prompt. Just to keep things tidy. If the response.recv, no, don't need the recv line anymore. Response.starts with authentication successful. Then we print happy face, found the password, it is blah, and we return it. Otherwise, we simply break out of this loop here and keep on trying more password characters. And if we get down to here, after having exhausted the whole range of max password len, we complain that we shouldn't have ever gotten here, and we return what we have so far, fingers crossed. So get password will have something returned to it. We're actually not going to use the password that's being returned. We're just going to print it out, because by the time get password returns, if it returned via this path here, it'll have already logged us in, and we'll have gotten back a message saying authentication successful, and when we return this prompt to people, they'll already have a privileged shell and they can run the flag command. So I'm not entirely proud of that, but it should do the job. Let's watch the syntax errors spew forth. Okay, so it's finding the password, but it's not actually trying it properly. Ah, I'm missing a space. Enable space plus password. Okay, we're getting blocked on something. What are we blocking on? Oh, we've decided we're not eating prompts, that's right. Have we decided we're not eating? No, we are eating prompts. The prompt isn't going to be $1 anymore, it's going to be a hash. Do we need to eat the prompt there? Can we just be lazy and just let turds accumulate and be cleaned out by nature? There we go. We got the password, it's password 1, and we've dropped to a privileged shell. Now we can run flag, and if the flag file was there, we could have gotten the flag. So that's that could have been done a lot nicer, I think. But you know what? Fuck it, I'm going to bed. We could have actually done a binary search. The issue with doing the binary search would be that I haven't done a binary search in Python. I'm not much of a programmer, as you can probably tell. more of a destroyer of worlds than a creator of them. So it would have been interesting to kind of come up with the pivot points and then go higher, lower, and kind of intelligently pivot and then make sure we're not kind of getting trapped in places where we're not rounding and actually pivoting and just flipping between two values. That would have sucked. We also would have had to basically, once we kind of wheeled our way down, actually kind of check one either side of the pivot point that ended up being the last pivot point to kind of see where this OXFF kind of triggered, so that we could have then known which character was the right password character. This worked pretty quickly over LAN anyway. I'm sure it wouldn't be so nice over internet, but it does the job. It's a little bit more noisy, a little bit more slow than it could be. And having to have this down here makes me feel awful. I would like to understand better how this would work for. Actually, you know what? Let's, out of curiosity, go and set a password that is 32 characters long and just see what happens. See if it still works. So that's 16 characters, that's 32 characters. Let's see how that would have held up. Failed at that. Was that too many? Oh no, OX 20 characters. No, OX 20, yeah, 32 characters. How long is that there? 16, 17, 18, 19. Yeah. 16, 17, 18, 19, 20, 21, 22, 23, 24. Why did it struggle to go further than that on that password there? Yeah, got it. Raw brute force, not binary search, worked fine. Yeah, exactly. I mean, we've got the luxury now. We've sort of got the luxury. I mean, I want to go to bed, but we've got the luxury of not being under time pressure. In a CTF, like I would have stopped before I'd even gotten this far. I kind of would have gotten the printout of one of those failing attempts and just kind of gone, that looks like a password. Typed it in, it would have worked. I would have moved on with life already. Outside of a CTF, we do have the luxury of checking the edge cases. Like, why is this edge case falling over? Have I seen how to? Might save me some switching of tabs. No, I haven't. How to, hey? Oh, that's kind of cool. Node.js. That's kind of cool that you can almost query it in like a natural language sort of thing and it will figure out what you're trying to do. That's really nice. I'll have to recommend that, yeah, to people who are learning the Linuxes. Very cool. You're not checking result, so it's going past the length of the password, I think. Something, null termination. Not checking result. I mean, is this password too long? How long can the password be? It can be OX 20 characters, yeah? What if we just drop a character? Is there enough by one issue? It's not getting past that 8 there. If we just cut it off at the 8, does it work? Bullshit, it's not. Is it getting read in weirdly or something? Or is it getting overwritten in BSS? Where is the password? Is it getting overwritten? Tell you there. That's not what I wanted at all. It's a 3B8. Is it getting read in weirdly or corrupted later on? Because that's not the password that I set. If we drop a character, does it work? Looks like there's maybe corruption going on. Maybe the password can't be that long. That's what I'm going with. Yeah, but I'm not doing that many characters anyway. Doing 23 characters. I'm wondering if it gets corrupted later on. Because yeah, you're reading in OX 20 characters. But I'm wondering if something else is corrupting it by writing to that section of BSS. There's a new line at the end of the file. There's a new line. Echo dash n 2 3 4 5 0 0 1 2 3 4 5 6 7 8 9 A B C D E F. Let's just do that for now. Home shitsco password. Try the exploit again. Okay, so I found that password. 0 1 2 3 4 5 6 7 8 9 A B C D E F. Stops in the same spot. Hang on, that's going 1 2 3 4 5 6 8. That's failing to actually figure out that character. It's thinking it's an 8 instead of a 7. So that's probably a bug on my behalf. What could that be? Let's go to the enable function again. Why am I stuffing up that character? Just going to print the response. Because of all the FFs. What if I change this to FE? Tripping over on an FF somewhere that it shouldn't be. Yeah, it's jumping from 6.5 to 6.8 when it's decided it's hit something. That's weird. Print response. Weird. Add a null to the passwords, I'm trying. Add a null to the passwords, I'm trying. Where could I do that? Go back to FF. -1. Candidate password plus equals null byte. So I actually null terminate what I'm sending. What's wrong with it now? No, it doesn't like the, because the way I'm sending it, doesn't like me putting that null byte there. Plus the leak is then, the leak's being terminated. Yeah, so I can't put a null byte in there, Kane, otherwise the leak doesn't happen. It actually, the printf will hit my null byte and then not leak anymore. So why is this failing for long strings? That looks fine. That looks totally fine. Why? Why is it getting all the way to 0, 1, 2, 3, 4, 5, 6 and then deciding the next character is 8 instead of 7? What's that 9 doing hanging out in there? What's that 9 doing in there? Why the 9? Why? Why am I leaking a 9? Because when I get the right character for that location, I'm not getting back something that's going to look like -1. I'm getting a ASCII 9. Hex 39. Why has this -1 been corrupted to be negative something else? Like, okay, so it doesn't just return -1, 0, or 1. It can return an integer less than, equal to, or greater than 0. Okay, so I should actually read in the full integer and check to see if it is... Yeah, I'll like struct.unpack it to be a signed integer and check if it's become less than 0, rather than checking to see if the first byte of it is hex FF. Alright, cool. That's my bad, that's a bug. I hadn't ever seen strcomp return anything other than -1, 0, or 1, not that I've seen the internals of it and what it returns that often. But yeah, so it looks like this here is actually a cheats test, and I really shouldn't be doing that at all. So hang on, if we go Python from 5 through to 9, do I get 4 characters? Yeah, I do. So really I want to do, I don't need that, I don't need that. If struct pwn.unpack32 response.split that through to 36 is less than 0. Unpack requires a string argument of length 4. Isn't that what I gave you? No, because when it's positive integer, there'll be null bytes that cause truncation. So really we need to pad with 0. So we go a dot, is it L justify? Yeah. Hex 0. Yep. So what we need to pad out what we get back. So response.split, really we need to that dot L just to be 36 characters long. No. No, 4 characters long. Padded with hex 0. This is getting horrible. If this was code going into any sort of production, it would be not. It would be very much addressed before that ever happened. Something's gone wrong with finish the loop. Great. Let's go leaked int equals like all this. Hex 0. Print leaked int. It's pwn.u32 is probably unsigned. Whereas I want it to be signed. Pwn p32. Which I want pwn u32. Sign equals signed. This is getting horrible. That's looking much better. Let's not print the leaked int. Perfect, right? Enable that. Can you not have a 32 character long password? Okay, cool. We can find characters that are 31 and 32 characters long. It's just that if we wanted to actually send up a 32 character long password, we would need to basically exploit the null terminator in there. Because we get the opportunity to have a stern copy of 32 bytes, which, because we'll be giving the full 32, will result in a non-null terminated string. Otherwise, we can do this here and use the... Nope, not that there. Yes, this here. The read command, which does not null terminate strings. And we get the opportunity to give OX 20 bytes. So, unless we could exploit a null terminator in there, because by the time we actually get to read into dest, by either of these two methods, the very next thing is the stir comp. And because our string will be overly long, we may fail the stir comp. So you may not even be able to log in at all with a 32 character long password. Like that's the password there, 0 through F, 0 through F. Is there any way to log in? Like we can... Like we can fall out of the loop with the correct password, lowercase f being the last character. That's totally fine. But if we do enable that, we get nope, and we can see the garbage here. If we do enable that, then we get garbage again. So I don't reckon you can log in. I don't think that the service, if it had a 32 character long password, where the last character of the password is something other than null byte, I don't think it'd let you log in at all. So I think the fact that we can get a 31 character password is success enough for me. Yeah, we can brute force a 31 character password and get access to the flag function. So cool, I think we've pretty well done that. The only improvement we could do, well, there's two improvements. First of all, we could binary search it rather than just search bottom to top. The second thing we could do is address the horror show that is MyPython. I don't think this here should be hit, except for the case of a 32 character long password, which you can't log in with anyway. This is a nice little safeguard to kind of tell the user, hey, you shouldn't be seeing this. There's a bug. There's probably a bug somewhere, or you're hitting some other corner case, like passwords with hex FFs or passwords with null. I don't know. That shouldn't be hit anyway. But this here's a horror show that I'm not very proud of. That could use some refactoring and some rethink, like pwn32 response.split on the word isn't space. Get the second element out of that split list. Go and carve out 4 bytes, pad it with zeros until it's 4 bytes long, and then unpack 32 it as a signed in like that. There's horrible. There's a lot here that could be revisited. But hey, I mean, a flag's a flag. That I think goes just far enough to win the challenge and to call it solved. So thank you very much. Stone copy doesn't know. Yeah, exactly, Kane. I don't reckon you could log in if there was a 32 character long password. I think you're stuck. Let's go and let's do the one last thing. Let's do the real password. Hey, thanks to Mongo. Go back to that echo. Quit that. Do that. And there we go. Found the password. Get the pound symbol. Do flag. Get the flag. I mean, I haven't set up a flag file, but in the case of a competition, that would return the actual flag. So thank you very much for sticking through with me. Thanks, Kane, for the tips. Thanks Mongo for the tips. If it weren't for you, I would probably be reading up on heap attacks and trying to find weird stuff in the set and the show. So thank you very much for your help. Thanks, Kane. Thanks, Parks. Victory indeed. You enjoy it. Thanks, Parks. That was up there, I reckon. I think that'd probably be the highlight. I'll scrub through the VOD and kind of pick out the highlight where I did the thing with the stuff and make that the Twitch highlight of the week. Mongo, thank you. No, thank you. I really appreciated your assistance and your tips, your IDA tips, your ideas, your nudging. I think your nudging was well timed. I think you let me suffer for just long enough before steering me and not telling me where to look, but saying, hey, just go look at the leak, and got there thanks to your help. So thank you, Mongo. Thanks everyone for sticking around. I really appreciated your company and your thoughts and your comments. And if you weren't here, I'd be doing the same thing anyway, but I'd just be really bored of doing it. So I appreciate your company as always. Hope you enjoyed it. I am not streaming this Sunday. I've got prior arrangements leading up to Christmas and stuff. And I'm thinking of taking like a week or two off sometime over Christmas to recharge the old batteries. When I do that, I'll be sure to let you know so that there's no turning up and wondering where I am. But until next Wednesday, hope you all stay safe. Hope you're all gearing up for hopefully some time off over the holidays. Spending time with loved ones, family, friends, drinking too much whiskey. Good to see some Binary Ninjas. If you're after more Binary Ninjas, down in the description below there's a link to OJ's Twitch. Go give him a follow. Go give him a hug when he comes online next. He streams about once a fortnight, it tends to be. OJ does some really cool stuff. Check out his YouTube channel as well. He did a really cool one last night that I'm looking forward to seeing because I was out rock climbing. You'd think I deserve a week off. Thanks, Parks. So yeah, if you want to see some more binary stuff, go give OJ a follow and a cuddle when you see him online next. Thank you very much for sticking around. Enjoy what you tend to do with your weeks. I don't know what it is. Kane will start streaming. Awesome. When Kane starts streaming, go give Kane a follow and a cuddle when he starts streaming. Dude, I'm looking forward to that. I'll be there. Take it easy, everyone. Hope you have a good week, and I'll catch you next time.